Hi class. Here's another video on how to convert particles to moles this time. So we're doing the opposite of what we did last time. We're going to start off with particles and we're going to convert them to moles. Again, the thing that allows us to do this is that we have a conversion factor. 1 mole is equal to 6.022 times 10 to the 23rd particles. And because this is a conversion factor, I can use it whichever way I need to. I can multiply by it, I can divide by it. And so we're going to try that out. So I'm going to start off by writing down my given number. So my given number is 5.69 times 10 to the 22nd particles of copper 2 chloride in this case. 10 to the 22nd power. And this is particles of CuCl2. Again, right now it doesn't especially matter because we're only talking about one thing, but when we get to stoichiometry, this is going to matter a little bit more because we're going to be talking about different reactants, different products. So in 1 mole, because this is what I'm converting to, the thing that I'm converting to in general goes on top. In 1 mole, I have 6.022 times 10 to the 23rd particles. So I have 6.022 times 10 to the 23rd particles. And I'll try to do this as quickly as I can. This is supposed to be a 23. And I'm going to call them P for particles. Alright, and when I do that, I need to divide this. What I'm going to recommend is that you put this number into your calculator, and that when you do that, you put these numbers in parentheses, because sometimes order of operations can mess up what you're trying to do. You only want the numbers in parentheses. You're obviously not going to put in the letters or particles or copper chloride. And when I do that, here's the number that I get. I get 0.0945. So we can talk about significant digits later, but there are 3 significant digits in this number. And I have moles. Moles is the thing that I wanted to get to. And the reason why I get moles is because particles cancel out. And if you look at it, I have particles in the numerator over here. I have particles in the denominator right there. They cancel out, and I'm left with moles. And of course, this is of copper 2 chloride, CuCl2. Alright. And so the question is, how do I know that this answer is right? And the answer is you can't be 100% certain, but you can be pretty confident because I can look at this number, 5.69 times 10 to the 22nd power, and compare it with how many particles I know there are in a mole. So I know that there's 6.022 times 10 to the 23rd particles in a mole. Here I have 5.69 times 10 to the 22nd. So I can see this is about an order of magnitude, or about 10, roughly less than 1 mole. So I would expect to have like a tenth of that. So maybe like 0.1 moles, and this is roughly 0.1 moles of copper chloride. Alright, so let's move on to the second one, where I'm trying to convert 8.210 times 10 to the 26 particles of strontium into moles. So again, I'm going to use my conversion factor, and what I would like for you to do is to try this on your own. So at this point, I would like for you to pause the video and try it on your own. And I'm going to go 3, 2, 1, and unpause. We're back. Alright, so start off by writing down your given number. So here I have 8.210 times 10 to the 26th power. And I know my cursor's a little bit slow, so I'm trying to work with you here. Times 10 to the 26th power. And again, this is particles. I'm just going to write P for particles, and this is of strontium. Strontium is Sr. And what I'm going to do is I'm going to multiply this by my conversion factor, and what things should go on top and what things should go on the bottom. Well, I want to convert to moles, because that's the question that they're asking. How many moles can I get? So here's what we do. We can actually shorten moles to MOLs, which I'll do to save time here. And then how many particles are there in a mole? Well, there's the same number we've been looking at for a while now. Avogadro's number is 6.022 times 10 to the 23rd particles. Right, so that's what we got, and I'm going to write P there for particles instead of writing it all out because that takes a lot longer. And so what I'm going to do is my particles will cancel out, And again, I want to make sure that I put these numbers in parentheses so that order of operations doesn't get me. But you can see anytime I multiply across the top, I'm just going to multiply by 1, so it doesn't make sense to do that. When I have a number in the numerator and denominator, I'm going to end up dividing by the number in the denominator. So I multiply across the top, I divide across the bottom. If I multiply by 1, I just get the same number. And when I divide by the bottom, I'm going to divide by 6.022 times 10 to the 23rd. And what I'm going to end up is with 1,363 moles. Now, is this number reasonable? And I'm just going to shorten this to MOL again. It stands for moles of strontium is SR. Does this number seem reasonable? And it's hard to say because we don't really think about things in terms of moles. But again, we can go back to our reference, our conversion factor. I expect 1 mole to have 6.022 times 10 to the 23rd particles. If I have 10 to the 26 particles, that's like 1,000 times more. That's 10 to the third more than this, which puts me like in the thousands number. So I have 1,000 times more particles, roughly speaking, than this number. So I should expect to have that 1,000 times as many moles. So 1,363 is roughly 1,000 times 1 mole, right? So this number does seem reasonable for that reason. Hopefully this helps. Good luck.